I'd like to obviously introduce our next speaker, Mark Lynas, who's going to give us, I think, a very different view of the world. And I enjoyed Mark's company over dinner last night, and it was going to be very interesting to hear what he has to say. So with no further ado, I'd like to introduce Mark. Thank you.
Thank you. It might be interesting, it might not, given that it might be interesting, it might not, given how late we all stayed up last night. I'm not a Scotsman, I'm from south of the border, and I can testify that the minister was fibbing about the summer weather. Today is atypical only because it's not raining very hard and it's still quite warm. Tomorrow you might be in a bit more luck on that front. Anyway, I'm going to talk on very broad brush themes here. When I was at university here in Edinburgh, I didn't study agronomy or anything like that. I did history and politics, so I'm not an agriculture expert, but I am somebody who spent a lot of time looking at the science of ecology, and I'm also a lifelong environmentalist, so that's the perspective I'm coming to you with today. And I think today we find ourselves at something of a crossroads. Science is telling us very clearly that the bounty of our planet is not unlimited, and that our ecology, the planetary ecology, is in danger of being irreparably damaged by human activities. Yet at the same time, perhaps for the first time in human history, we find ourselves at a very positive juncture where we can potentially banish poverty and want to the margins of human society for the first time ever. Now, I want to start with talking about what I call the 2050 challenge. You probably heard about this from John Beddington yesterday as well. And that is, of course, to support a much larger world population of 9.5 to 10 billion people at hopefully Western first world living standards by 2050, and to do so within the constraints of the planet's limited ecological space. And I want to quickly run through a new conception of what these planetary ecological limits might be, quantified and defined by a scientific team led by the Swedish professor Johan Rockström. And they looked at the whole global picture, and it suggested that all of the environmental problems are essentially reducible to just 9. And these they termed planetary boundaries. Now, the first one I think is very familiar to all of us. There's no doubt that biodiversity is in very deep trouble worldwide. No one knows precisely what the current level of extinction rate is, but it's very high. People talk about us being in the 6th mass extinction, the worst one since the dinosaurs. Certain groups like amphibians are in really deep trouble worldwide. And of course, because the number one driver of biodiversity depletion is habitat loss, agriculture is very seriously implicated in this. And we're essentially, when we're farming, we're competing with wild animals and plants for land area to feed ourselves. And the scientists tell us, I won't go through the figures precisely, but that we're well into the danger zone in terms of the biodiversity loss issue. Moving on to climate change, this is something I've spent years working on. I've written 2 books about climate change. And having done all that work, I don't think there's any serious doubt that global warming is real, that the planet is warming up, and that human activities are at least substantially to blame for that. Now, most of this, of course, comes from fossil fuel burning for energy, but agriculture is probably the second largest contributor, both from energy use in agriculture and because of carbon released through land use change. And of course, there's nitrous oxide emissions from the use of fertilizer on land. And again, I won't go through the figures, but the scientists are saying that we're over the red line, certainly in CO2 terms for this. Now, here's one which is familiar to all of you. When I do this presentation, for most audiences, people don't have a clue who these 2 guys are, but I expect you all to know them because your livelihoods depend directly on their work. So on the count of 3, you can all shout out who they are. 1, 2, 3. Very good. So Fritz Haber and Carl Bosch. Nobel Prizes, richly deserved, who gave us the ability to synthesize ammonia from atmospheric nitrogen, without which we'd be in a world of structural famine, which was indeed the situation that looked to be looming in 1900 when the challenge was first made to feed the world through the technologies being developed in the laboratory. And this is also what says to me, again, and I say this as an environmentalist, that organic farming can only ever be a tiny niche market. The nitrogen has to come from somewhere, essentially. Now, the scientists involved in the planetary boundaries exercise are telling us that we're 3 times over the limit in terms of what the total quantified use of fertilizer can be because of the issues of eutrophication in freshwater ecosystems and oceanic dead zones. Personally, I think we should exercise serious caution in taking this too literally because we've got to feed the world's population and because land use is also a boundary. And if we were to dramatically reduce fertilizer use and turn the world organic, then we'd have to dramatically increase, probably double, the amount of land area devoted to agriculture, which would then have knock-on effects on biodiversity, of course. So you've got to see the interrelationships between these planetary boundaries and figure out something of these, of how these trade-offs are essentially unavoidable. I think if we were to turn the world organic, we'd probably end up ploughing up most of the world's rainforests within about 10 or 20 years. Another proposed boundary, if I move on quickly, is water use. And for both land use and water, it's per unit productivity, environmentally, that matters most. In your case, this is what quantity of potato yield you can get for a given amount of land and water. Now, here I've concluded that whilst there are undoubtedly some very serious ecological issues raised by modern agriculture, it's also underrated in many senses because it's incredibly productive in terms of its land and water use. Indeed, there's a lively debate in the academic community over this idea of land sparing versus land sharing. This is more of a biodiversity issue. But the idea is, should we try and increase the amount of wildlife that we're sharing the land with in agriculture, or should we be as intensive as possible on a smaller space and then leave the rest for pristine nature? And of course, this isn't black and white, but it seems to me that the land sparing argument is in the lead at the moment. Moving on quickly to another boundary proposed, aerosols. This is essentially about air pollution. A lot of it does come from the burning of agricultural biomass. Obviously, a lot more comes from industry, particularly in China. In South Asia and India, biomass burning is the biggest contributor by far to this Asian brown cloud, which is talked about, which you can see blanketing the Himalayas at the beginning of an average summer. Another issue familiar to us all, by the way, there's no quantification proposed for this boundary because it's simply too complicated. Another area which is familiar, perhaps more so, is toxics, the use of toxic chemicals, another big issue of concern to people involved in agriculture. Enormous uncertainty here about the interrelated effects of different pesticides in the environment, but at the very least, we can all agree that they need to be minimized. And for me, again, as an environmentalist, as a green, this is possibly the most promising area of GM research, because by genetically modifying crops to protect themselves, we can reduce the amount of times they need to be sprayed. And I'll talk a bit more about that in a minute. Again, there's not a quantity put on this. Boundary number 8, ocean acidification. This is the other issue with CO2. If you dissolve carbon dioxide in the oceans, you get essentially a weak carbonic acid, which is not good news if you're a calcium carbonate life form. So this is why we absolutely have to deal with the carbon dioxide problem, not just because of climate change, but because of ocean acidification as well. Last but not least, the one and only success story we have, which is the ozone layer. You might not know who the inventor of CFCs was. Can anyone name him? Thought not. He's actually a guy called Thomas Midgley, who worked for General Motors back in the 1920s and 30s. He also gave us lead in petrol. So those two inventions combined, that and CFCs, made him, in the words of historian John McNeill, he had more impact on the atmosphere than any other single organism in Earth history. And I think that's probably true, actually. This is the success story, as I say. Now, looking to the future again, let's go back to the 2050 challenge and start by looking at progress that we've made so far. Again, when people give environmental talks, it's often simply bad news, gloom and doom, how everything's getting worse. I think we need to remember how much better things have got already, and very rapidly so in just the last few decades. The number of people worldwide living in extreme poverty, so on less than $1.25 a day, has fallen from 43% in 1990 to just 22% today. That's a massive drop. The Millennium Development Goal for halving poverty has already been achieved 5 years early. That was achieved in 2010. You don't hear this stuff in the media for some reason. And of course, the epicenter of that development miracle has been China, which successfully lifted 500 million people, more than 500 million people out of poverty in just a quarter of a century. How was this progress achieved? Well, primarily through rapid economic growth. And this isn't just something which is going on in the famous emerging economies. It's now much broader based. You can see I've got some figures on the left-hand column here for African countries, for South American countries. You look at Peru averaging 6% economic growth for the whole decade. This is the average over the decade. It's not just a single year. Ethiopia, 8.8, what is it? Nearly 9% for over 10 years. You've got a rising middle class now in Addis Ababa. You've got coffee shops. And, you know, I grew up in an era when Ethiopia was famous for famines, and hopefully that thing is now in the past forever. Then on the right, you've got the BRICS, led, of course, by China. Look at the contrast with North America and Europe. Obviously, we know Europe is in a state of constant economic collapse. But even over the 10 years from 2000 to 2010, before the big recession hit, economic growth is tiny. It's less than 2%. So what you're seeing here is a real reduction in global inequality. The divide between the developed and the developing countries has less and less meaning with every single year that passes, and I think that's something that must be celebrated. However, this drives, because we're reducing poverty so rapidly, this drives an increasing demand for raw materials to fuel the increased consumption, which is what poverty reduction means in sense by definition. Now, many commodities as a result are at historic highs in terms of their prices. Even looking back to the 1970s, if we normalize at 2005, as you can see here, pretty much everything is higher in real terms than it was in the 1970s, particularly the case for energy. I imagine that's because of the high oil price primarily, same as also huge increases in the cost of fertilizer, which is another major area of concern. Now, the other big issue in terms of the growth in demand is population growth. So you've got reduction in poverty on one side, and you've got the increase in population at the other. Another quiz here, just to get you all going. I find that people get this wrong, and I hope you do get it wrong, but let me have a go. What do you think the current fertility rate is in terms of its global average? Now, obviously, 2.1 children per woman is what you'd term natural replacement. So is it 4.5 children per woman, 3.5 children per woman, 2.5 children per woman, or 1.5? So is it already below natural replacement? Now, how many of you think it's A, 4.5? Just a couple, a few, sprinkling. 3.5? Okay, how about 2.5? So that's about even, isn't it, between 2.5 and 3.5. And 1.5, below natural replacement? A couple of you still. Okay, well, the real figure is 2.5. And those of you who got this wrong, you're in good company, because the American Association for the Advancement of Sciences, the global elite of knowledge makers, got this completely wrong. Most of them went for 3.5. People habitually overestimate the number of children who are being born, and hence you get this focus on family planning and a constant, I would even say, obsession with the need to reduce the amount of children people are having. Actually, the reality is that global average fertility has already dropped precipitously and is now at 2.5, close to natural replacement. So why is population still growing? It's growing almost entirely because of declining mortality, especially infant mortality. Now, as a father myself, a father of 2 children, I think it's a good thing that more children are growing up to have children of their own rather than dying young from poverty and preventable diseases. Now, that's why we've got a growing population, simply because people are living longer and living long enough to have their own children. And that's something we've got to welcome. But all these children have to be fed, and they have to be fed, I think, within the ecological constraints of the planet. How do you do this? Well, there's this buzzword of sustainable intensification. Essentially, for me, this means driving further productivity increases. The 2050 challenge means that you have to double food production at least. The FAO says increase by 70%. I think they're wrong. I think it's going to be 100%, 120%, something along those lines. We know that big productivity increases are possible because they have happened in the past. If you look at some of this data here, I know this is for cereal yield rather than potatoes, but it's the same kind of illustration. if you look at the bottom for the world as a whole, the percentage of agricultural land, 38% in 1990, 38% in 2007. Exactly the same area of land is being cultivated, and you look at how yields have increased, 2,700 kilos, so 2.7 tons per hectare, up to 3.5. This is global averages, so a very broad brush figure. But again, you've seen major yield increases for exactly the same amount of land. And there's less land being cultivated in China, as you heard earlier, and also in the EU, and also in the United States. Also, the US and the EU are using less fertilizer. Big increases in fertilizer in China and also to a lesser extent in India. One thing to note here is the yield gap. Look at how little African farmers are using in terms of fertilizer, and look how little productivity they're getting largely as a result. So this suggests to me we're nowhere near absolute limits in terms of what productivity can be. It can be increased hugely, at least to deal with the yield gaps, and also driven further in developed countries as well. Moving on to some potato-related issues. You know that the potato is the world's third or fourth most important food crop. I had a big debate last night whether it was third or fourth. It depends who you talk to. But either way, it's extremely important. It has big advantages in terms of the planetary boundaries, which is what interests me. And it's extremely water efficient, much more so than cereal, 7 times more. And is also more land efficient. You get much higher yield of food if you're planting potatoes than if you're growing cereals or something else. And to look at some of the challenges, so what are we going to have to really deal with? Yields have barely increased at all in the UK in the last couple of decades. I imagine this is a trend which is probably shared in other developed economies. You'll know a lot more about this than I do. I think this is something we've got to look at. Obviously, the drivers haven't been improving yield per unit of ecological limits, but I think that's increasingly going to be the case as we run up against some of the limits at a global scale. We've got to deal with the African yield gap, as I said. There's also major issues with pests, especially with regard to our old friend blight. And given that blight control can mean 15 or more sprays in a single season, a spray per week as soon as the potato comes up, from what I've heard, I think getting a blight-resistant GM potato is an environmental imperative. And I simply can't understand why there's such opposition to this idea. Not only because potatoes don't cross-pollinate in any conventional sense like other crops do, but because propagation, of course, happening by tuber is clonal. So what could be the possible objection to this? In fact, the minister's left now, so I can say this without breaching diplomacy. But I do think he spoke about Scotland's historical role in fostering knowledge and reason, I think that was his word, in the age of the Enlightenment and since then. And today, Scotland has a policy of being GM-free, based, I hate to say, not on knowledge and reason, but on ignorance and superstition. And, you know, and I really feel strongly about this. If you... All right, we can email the minister and tell him I got a clap for this. But I think it's true. If you try to stop technological innovation, you betray that fine tradition of the Enlightenment, and that's not something that should be taken lightly. And that's a policy. This GM-free policy is one that must go if Scotland is to continue to be a leader in the future. Now, just to wind up, I think, as I said earlier, productivity is essential for meeting this 2050 challenge of feeding the world within ecological limits. And I think you've got to, again, to re-emphasize this point, you've got to think about yield as a return on all the factors of production, and particularly land, water, and fertilizer. We've got to double world food production, and we've got to take the successes of the Green Revolution to Africa. Let's also get away from this black and white thinking of what's organic and what is not. My dad, by the way, is an organic farmer. He's desperate for a GM blight-resistant potato. And when he asked the Soil Association why he couldn't have it, they just went on about Monsanto and stuff. So they don't have a clue. Why? You know, this is just outdated thinking. It's a narrow mental boundaries which I think need to be superseded. Lastly, let's remember that this 2050 challenge isn't some awful duty which we should approach with dread, but a colossal business opportunity. You've got vast new markets opening up in newly prosperous countries which are finally escaping from poverty and from centuries of forced subsistence farming. Now, for me as an environmentalist, this new prosperity is not something to be feared, but I think it's something to be celebrated. What's good for humans can and also should be good for the planet, and it's up to you all to figure out how this can be done. Thank you very much.
Well, thank you very much, Mark. I suspect that's the headline of the day. And that should make an interesting conversation this evening. Well, thank you both to Professor Lieping and to Mark Lynas for fascinating presentations. In China, for those of you who haven't been, it's an incredible country, and it's fascinating to see how the world's biggest producer of potatoes has so many different climates, so many different ways of growing potatoes, and such a variety of innovation, and also represents a huge market opportunity, I think, for many other countries around the world for agricultural investment. Mark's presentation was enlightening, I think, in that it offered a much more positive view of the future than we often hear. And I noticed that he linked beautifully into the fact that China's lifted 500 million people out of poverty. And I think that's a very important point for us to take away. So some good news about also economic development in many of our poorer nations around the world, and a more positive view, while we're languishing in recession in the West, of the fact that quietly there are many other nations around the world that are moving their economies forward and improving the living standards for everyone. On GM resistance, a subject very close to the heart of many people in this room, I'm sure, we had a view about the opportunity, particularly with blight resistance, to bring an environmentally friendly route forward, perhaps, a subject for much debate, I'm sure, and considerable policy issue in Scotland, I can tell you. So finally, really a comment that the new prosperity is not something to be feared, but something to be celebrated. I think that's a great close. Thank you, Mark, very much indeed. Okay, we now have a coffee break. We're returning, let's see, what time is it? We're at 10:30. We're a bit ahead of things here, aren't we? Coffee's coming out early, okay. This session was due to finish in quite a while, so we're actually got quite a big coffee break, so there's an opportunity for people to have a good chat. And we're returning at 11 o'clock, is that right? 11 o'clock back here, thank you very much.